A cataclysmic eruption has rocked Mount Etna, unleashing a spectacle that has left the world breathless and scientists reeling in disbelief. From the molten depths of this iconic volcano, a bizarre, radiant substance has emerged, glowing with an otherworldly light that defies every known chapter of geological history. This luminescent enigma, unlike any material previously recorded in Etna's fiery chronicle, has sparked a frenzy of awe and dread. Experts are stunned, grappling with a phenomenon that shatters their understanding of volcanic behavior. As emergency teams scramble to unravel the mystery, early tests reveal this substance matches no known geological emissions, igniting fears of an unprecedented volcanic event, or something far more sinister brewing beneath the Earth's crust. Local communities tremble with unease, their lives overshadowed by the volcano's cryptic warning, while researchers race against time to decode its message. This eruption, reaching a terrifying crescendo at 11:23 a.m. local time, unleashed a pyroclastic flow that tore down Etna's eastern flank at a blistering 140.4 kilometers per hour. A searing avalanche of incandescent rock, volcanic ash, and poisonous gases surged downhill, sparking panic as tourists and onlookers fled in terror, pursued by a towering wall of fire and smoke. In just 60 seconds, the flow devoured 2.34 kilometers, and within 84 seconds, it scorched a path stretching 3.26 kilometers, leaving a charred expanse of 2.64 square kilometers. Yet, the term scorched barely captures the devastation. This barren landscape, repeatedly ravaged by prior lava flows, stands as a desolate testament to Etna's unrelenting fury, where plant life is a distant memory. This apocalyptic sequence followed an earlier eruption that began at 5 a.m., sending molten lava cascading 2.7 kilometers across the rugged terrain over 7 grueling hours. Footage shared across social media captured faint wisps of white volcanic gas rising from the lava's leading edge, a haunting sign of 4 distinct lava lobes surging forward. This eruption unfolded within Valle del Bove, a vast chasm carved by a catastrophic landslide around 7,200 BCE, when 25 cubic kilometers of Etna's flank collapsed into the Mediterranean, triggering a colossal tsunami. Today, this ancient wound serves as a natural basin, its steep slopes channeling molten rivers through treacherous pathways. The valley remains one of Etna's most perilous regions, with no official trails daring to traverse its upper reaches due to relentless volcanic threats. Despite the chaos and heart-stopping visuals flooding online platforms, no lives were lost. The closest visitors, stationed 0.8 kilometers from the pyroclastic surge's edge, stood in zones where the flow's momentum had begun to wane, sparing them from its wrath. What sparked this cataclysm was no ordinary eruption, but a paroxysm, a ferocious, short-lived explosive event that disrupted Etna's usual rhythm. Known for their sudden onset and devastating power, paroxysms can manifest as strombolian or Volcanian eruptions, or, in rare cases, the catastrophic subplinian or Plinian types. This week's paroxysm unleashed one of the most extensive pyroclastic flows witnessed on Etna in over 3 decades. A chilling reminder of the volcano's unpredictable might. Uniquely, it paired with a strombolian eruption, an unusual combination, as strombolian activity rarely triggers such flows. Yet, under specific conditions, when a lava front or vent becomes excessively steep or unstable, a collapse can unleash a pyroclastic surge. This flow, glowing with a reddish-brown hue, hinted at a high concentration of scoria, a porous volcanic rock. Though pinpointing the exact source remains elusive, preliminary data suggests it originated between the primary vent and a point 250 meters to the north-northeast, with the explosive phase igniting at 8 p.m. on June 1st, peaking during the pyroclastic onslaught. Mount Etna's latest eruption has captivated the world, not only for its raw power, but for its tantalizing clues about Earth's hidden depths. Historically, Etna's paroxysms follow one of 2 paths, a lull in activity or another explosive episode within days. This duality underscores the volcano's maddening unpredictability, a trait that both terrifies and fascinates. Each eruption serves as a geological messenger, carrying materials from Earth's inaccessible interior to the surface, offering scientists a rare window into the planet's core. Unlike other Italian volcanoes, shaped by the subduction of the Ionian Sea beneath the mainland, Etna's origins are more complex, driven by a unique convergence of tectonic forces. Its lava bears a hybrid signature, blending mantle-derived elements like magnesium and iron with crustal components like potassium. This dual-origin magma, drawn from both the mantle and the overlying crust, provides a real-time glimpse into Earth's inner workings, making Etna a geological anomaly that continues to rewrite the rules. Volcanoes worldwide are not just agents of destruction, they are alchemical forges, crafting treasures that shape civilizations. Mount Erebus in Antarctica, one of Earth's most active volcanoes, spews up to 80 grams of gold daily into the atmosphere, a glittering testament to its subterranean wealth. The ancient McDermott caldera, straddling Oregon and Nevada, harbors what may be the planet's largest lithium deposit, a resource powering the renewable energy revolution. These geological titans do more than reshape landscapes. They fuel innovation, from battery technology to sustainable resource extraction. Beneath their fiery exteriors, volcanoes conceal a dazzling array of minerals, forged under unimaginable heat and pressure. As magma surges upward, it carries elements like gold, silver, and platinum, depositing them in veins that become vital to industries and ecosystems alike. Each eruption is a chapter in Earth's story, revealing ancient processes and ongoing transformations that connect the planet's molten core to the surface we inhabit. Silicate minerals form the backbone of volcanic rocks, weaving the structural and chemical fabric of Earth's dynamic crust. Feldspar, the most abundant mineral group, dominates with its plagioclase and orthoclase varieties. In volcanic settings, plagioclase is a cornerstone of basaltic and andesitic lava flows, contributing sodium, calcium, potassium, and aluminum. Olivine, with its magnesium and iron-rich composition, is a hallmark of basaltic lava, often erupted by shield volcanoes like those in Hawaii. As magma cools, olivine crystallizes first, forming vivid olive-green crystals that release vital nutrients into volcanic soils. Pyrocene and amphibole, dense and dark, are iron and magnesium-rich minerals found in mafic and intermediate rocks, offering clues about the pressure and temperature within magma chambers. Mica, particularly biotite, appears in silica-rich rocks like rhyolite and dacite, releasing potassium that nourishes post-eruption ecosystems. Oxide minerals like magnetite and ilmenite, rich in iron and titanium, hold industrial value, while sulfide minerals like pyrite and chalcopyrite form in hydrothermal systems, especially around submarine vents known as black smokers. These underwater hotspots are crucibles of mineralization, shaping oceanic geochemistry and economic geology. Volcanic gases, though deadly, play a pivotal role in mineral formation. Sulfur dioxide, emitted in vast quantities, reacts with oxygen and water to form sulfuric acid, which interacts with rocks to produce minerals like gypsum or native sulfur. Volcanic ash, often dismissed as a nuisance, is a geological powerhouse, composed of fine shards of volcanic glass and minerals like quartz, feldspar, and zeolites. Over time, ash enhances soil texture, boosts water retention, and fosters plant growth, transforming barren landscapes into fertile grounds. Along tectonically active zones like the Pacific Ring of Fire, volcanoes deposit trace elements, gold, silver, and platinum group metals, carried by hydrothermal fluids and concentrated over millennia. These precious metals underpin mining industries and highlight the intricate dance between geological forces and human progress. Across the globe, volcanoes stand as both destroyers and creators, yielding treasures that fuel innovation and sustain life. In Siberia, the Mirny mine, perched atop a prehistoric kimberlite pipe, once delivered diamond-rich magma from over 150 kilometers beneath the crust. These diamonds, prized for their clarity and industrial strength, were propelled to the surface by ancient eruptions, making the site one of the world's most prolific diamond mines. In northern Tanzania, Ol Doinyo Lengai, erupts nitrocarbonatite lava, a low-temperature flow rich in sodium and potassium carbonates. This lava carries rare earth elements like strontium, lanthanum, and neodymium, critical for high-efficiency electronics and renewable energy systems. In East Java, Indonesia, Kawah Ijen's glowing blue flames and acidic crater lake conceal vast sulfur deposits, harvested under extreme conditions for agriculture, medicine, and chemical industries. The volcano also yields selenium and arsenic, essential for metallurgy and electronics. In Ethiopia's Afar Depression, Erda Aile's persistent lava lake radiates heat from a tectonic rift, surrounded by sodium carbonates, halite, and potash formed from evaporated volcanic brines. These resources support agriculture and industry, while the rift's activity hints at deeper, undiscovered deposits. In Papua New Guinea, Lihir Island's submarine volcanic system powers the Lihir gold mine, one of the world's richest epithermal gold deposits. Here, gold is entwined with pyrite and quartz, alongside tellurium and antimony, critical for semiconductors and solar technology. The mine harnesses geothermal energy, blending volcanic power with sustainable innovation. In the Caribbean, Montserrat's Soufriere Hills volcano, reawakened in 1995, has revealed gold, silver, and copper deposits within its hydrothermal zones, though persistent volcanic risks hinder large-scale mining. In Iceland, Hekla's rhyolitic lava and geothermal fields yield zircon, thorium, and lithium-rich fluids, fueling advances in ceramics, nuclear technology, and energy storage. Japan's also caldera, with its steaming vents and hot springs, emits rare elements like tellurium, selenium, and bismuth, hinting at untapped reserves for electronics and renewable energy. In the South Pacific, Fiji's Tuvalu volcano harbors a rare gold deposit within an alkaline volcanic system, enriched with bismuth and antimony. Its high-purity gold, aligned with quartz veins, makes it a compact yet valuable resource. In Antarctica, Mount Erebus's icy flanks exhale volcanic gases that crystallize into exotic minerals like anorthoclase, berkite, and sodium-rich feldspar. Its extreme environment mirrors the cryovolcanism of Jupiter's and Saturn's icy moons, offering insights into extraterrestrial geology. These volcanoes, from tropical rifts to frozen peaks, are elemental forges, crafting the raw materials of modern civilization, from smartphone circuitry to electric vehicle batteries. Their fury births creativity, their depths yield treasures, proving that Earth's most volatile forces are also its greatest benefactors. Yet, the dream of mining directly from a lava crater or lake remains a tantalizing impossibility. Temperatures soaring between 1,000 degrees Celsius and 1,200 degrees Celsius would annihilate even the most advanced materials, while toxic gases, sulfur dioxide, carbon dioxide, hydrogen sulfide, and hydrochloric acid pose lethal threats. The ground near lava lakes is a shifting nightmare, where seemingly solid terrain can collapse without warning. Even cutting-edge drones and probes, tested by institutions like NASA, succumb to the blistering heat and corrosive atmosphere. The economic case is equally bleak. While lava contains trace elements like iron, magnesium, and titanium, these are dispersed, not concentrated for mining. Valuable metals like copper, gold, and silver form in solid hydrothermal veins, far from molten pools. For now, science relies on remote tools and drones to collect solidified lava and gas samples, deepening our understanding of volcanic behavior. Speculative visions of AI-guided robots and ultra-durable materials persist, but the heart of an active volcano remains an untouchable frontier, a humbling reminder of Earth's raw power. This eruption at Mount Etna is more than a geological event. It's a wake-up call, a stark reminder of the planet's untamed might and boundless generosity. Each surge of lava, each plume of ash, carries stories of creation and destruction, weaving a narrative that spans eons. From the glowing enigma of Etna's latest outburst to the hidden treasures of volcanoes worldwide, these fiery giants shape our world in ways both seen and unseen. They sculpt landscapes, enrich soils, and fuel industries, all while whispering secrets of Earth's molten core. As scientists race to decode Etna's latest mystery, the world watches, spellbound by the volcano's power and the promise of discoveries yet to come.